All right, so now we want to practice simplifying exponential expressions. Simplify, write answer with positive exponents only. Okay, so again, it's kind of how you look at it. Generally, if there's no simplifying in the parentheses and there's an outer exponent, I'm going to bring that in. So it's going to be 6 cubed, I'll have to figure that out, m to the 6th power, because 3 times 2, n to the negative 3 power. Okay, and I know I can't have a negative exponent, so I'll have to deal with that too. 6 cubed, it's 6 times 6 times 6. I believe it's 216. My m to the 6th, that's okay. But this part, see, that's got that negative exponent, so it's got to go down, downtown. So I'm going to have that for my answer, and I'm fine with that answer. All right, let's go to the next one. They all have a base of 17. And it's multiplication, so I could add up those exponents. 17 to the 5, and then I got to add a negative 4 and a negative 3. So that's negative 7 and 5, that's negative 2. 17 to the negative 2. Okay, a couple things. First of all, it's a negative exponent, so 1 over 17 squared. But do I want to know what 17 squared is? I think it's 289. I think we had that in another problem. I have to grab a calculator and check these, but I'm pretty sure it's 289. Okay. This last one, well, it's not the last one because there's some more, but this one's a little bit tricky. If you look inside the parentheses, you see that there's a v in the numerator and a v in the denominator. Those can be simplified. So sometimes I think the easiest thing to do is see the negative exponents, just take care of those right off the bat. So I'm going to put the u in the denominator. I'm going to have this v stay in the numerator, and I'm going to bring this v up. I think that's the easiest way to do it. I haven't done anything with the outer exponent. Now, you might say, well, that's like a magic trick. She's just moving stuff around. Okay, a negative exponent means you're in the wrong place. If you're a negative exponent, you either move downtown or you move uptown and you become positive, okay? If you don't like that though, another way you could do it is you could say, all right, u to the negative 1, and then it would be v to the 1 minus a negative 1, right? Because v's, that's division, that's subtraction, right? So you have a 1 minus a negative 1. All right. So I'm doing it two ways, aren't I? I said I wouldn't do that, but I am. All right. In the numerator, I have, back to my orange way, v squared over u, the whole thing squared. So that's v to the 4th over u squared. I don't have any negative exponents, so I'm happy. Okay, what happens on the other side here, since I'm doing it two ways here? I'd get u to the negative 2. Oh, I don't want to do that. Sorry. I don't want to bring it in yet. U to the negative 1, V. Okay, what's 1 minus a negative 1? That's 1 plus 1, or 2. Wait, now I can bring the outer exponent in. So I get U to the negative 2, V to the 4th, but I have a negative exponent, so he's got to move downtown. You do not have to do every problem twice, but those were two different ways to do it. There's probably more ways to do it, but that's just, I kind of like the orange way, but you know, whichever way works for you. Okay, what else do we have here? We got a bunch of stuff being multiplied. Why is that C? I think this should be an E, but anyway, we'll skip over that part. See the negative 5, or I'm sorry, the negative 2 and the 5? You're just going to multiply those. And then A, you've got the 3 here, and you've got a negative 2. This is all multiplication, so we're just adding exponents. That's a to the 1st. We don't normally put a 1, but 3 plus negative 2, that's 1. And then you got the B's. Okay, so like you could write b to the negative 1 plus 2. Okay. You don't have to write the negative 1 plus 2, but you could. Now, normally if the exponent's 1, we don't write it. So we would just put negative 10 AB. And we're done with that one. Okay, now D. It's really helpful. You got kind of an odd looking, base here. And you might be tempted to do it like the last problem and get, all fancy and stuff. But here's the thing. It's the same inside the parentheses, right? So I could add those exponents and something really nice is going to happen because 4 and negative 4 is 0. Try to make it sound all exciting. So the whole thing is just a 1. That is exciting. Okay. What have we got on the last part here? Well, you've got to take them piece by piece. The bases aren't the same and the exponents aren't on the outside aren't the same. So you're going to have to go 3 to the 5th power, w to the 10th, and then in the bottom it'll be 6 squared, and w to the negative 4. Okay. Well, I'm not a big fan of having to write out that 3 to the 5th. But probably that's what you'd want to do. I think 3 to the 5th is 243, if I remember right. And 6 squared is 36. So now I'm just doing that, multiplying out those bases, that 3 to the 5th and the 6 squared. I know that 9 is going to go into both of those. So how many times does 9 go into 243? 27 times? Okay, let me just check. A calculator, that you could do this with a calculator. Okay, it was 27. And then 9 goes into 36 4 times. I didn't want that long. I didn't want that long bar there. So just make it 27 over 4. Now I'm going to have w to the 10 minus negative 4. And so what I'm going to get in the end here, 27 over 4, I would not put a decimal. I would leave it as that fraction. And that's going to be w to the 14th. And I would leave it like that. Or I would write it as 27w to the 14 over 4 like that. Either one of those two ways would be fine. Okay, that's a long video.